For the second problem, we have the engine that's hanging by the couple of chains, and attached with that problem we were given the free body diagram for the engine, which is on the left, and the free body diagram for the ring O, which is on the right. And notice that if we use the known fact that the engine is not falling or accelerating, then the sum of the forces in the y direction for the engine is 0, which means that T1 minus the weight of the engine has to equal 0, or that the tension T1 equals the weight. And now if we look at, similarly for the ring, we have two parts. We have the sum of the forces in the x direction equals 0, which implies that if we look at the T3 parts, we have the tangential component and we have the vertical component of T3. And notice that T3 cosine theta is to the right, so that is a positive value. And then T2 is to the left, which is a negative value. And the sum of those two has to equal 0 because the engine, again, is not accelerating. And if we use the same thing, the same condition for the sum of the forces in the y direction for the ring, we notice that we have T3 sine of 60, which is pointing upwards, minus T1 equals 0. And now we have a set of equations. We know that from this equation, if I call this equation 1, equation 2, equation 3, so equation 3, we can say that T3 equals T1 over sine of 60 degrees, but T1, remember, is the weight, so we have the weight over sine of 60 degrees, which is the same as about 1.2 times the weight. And if we look at equation 2, we can say that T2 equals T3 cosine of 60 degrees, but T3 is the same as 1.2 times the weight times cosine of 60 degrees, which gives us 0.58 times the weight. So we can say that we have now found the tensions in terms of the weight if we so want to. If we know the weight, we can plug in the value for W inside and find T1, T2, and T3 accordingly. Since we're given that W equals 1500 kilograms, then T1 is the same as 1500 kilograms times 9.8 meters per second squared. And if we do this using our calculators, we can find out that this comes out to be 14,700 newtons. T2 is 0.58 times this 14,700 newtons, which would equal 85, 26 newtons. And lastly, T3, which equals 1.2 times 14,700 newtons. Will give us 17,640 newtons. So, depending on what the weight of the car is, we have it, the different tensions. But notice, folks, that if we use the solutions that we got in terms of the weight, then no matter what weight we have, we can easily find the tensions according to this. So we solved it generally first and then plugged in the value of the weight. And notice that we had to multiply the weight by 9.8, the mass by 9.8 in order to get the weight.